Hello everyone. In this video, we'll understand what really happens when any distribution system fails and why handling those failures is one of the hardest problems in system design. Most of the people think failures are rare in software system, but in reality, in distribution system, failures can happen anytime due to server crash, network failure, or maybe database not responding. And companies like Google, AWS and Netflix, their design system assuming that failure will happen. So in this video, I will make you understand what really happens when any distribution system fail and how real system handle those failures. So let's start.
So let's start with a simple setup. Imagine we have user who is using one application server and one database. The user sends a request, the application processes it, and the database stores the data. Simple. Now, for small traffic, this setup actually works fine. But imagine this server suddenly crashes, maybe because of high traffic, memory issues, hardware failure, or maybe deployment problems. Now, the entire application becomes unavailable. This is called single point of failure. One server fails and the whole system goes down. To solve this problem, companies move towards distributed systems. Instead of one server, we now have multiple servers. Request first go to load balancer. The load balancer distribute traffic across multiple application servers. Now, if one server crashes, traffic can still go to healthy servers. This improves availability, and this is one of the biggest reason why distributed system exist. But distributed system also create entirely new challenges. Now server must communicate with each other. And once system communicate over a network, new failure begin. For example, network latency. In distributed system, server communicate over a network, and network communication always takes time. Even a small delay becomes important at scale. So now engineer must think about response time and performance. The second problem is packet loss. Sometimes what happens is data sent over a network never reaches the destination. The request may disappear completely. And now the system must decide, should we retry the request or should we fail the operation. Another common issue is timeout. One service may wait too long for another service to respond, and after some time the request simply fails. This becomes very common in large distributed systems. Now, let's talk about inconsistent data. Imagine multiple servers updating the same data at the same time. One server may have latest information while another server still has old data. Keep data consistent across systems become difficult. Now, partial failure. And this is one of the most important concepts in distributed systems. One part of system may fail while the rest of the system is still running. For example, one server may think another server is down when actually the network is just slow. And this makes distributed system much harder to design. This makes distributed system much harder than single machine systems. Now, once system becomes distributed, engineer must think about retries, synchronization, consistency, replication, and fault tolerance. This is why distributed systems are considered difficult. Now, we'll see how real systems handle those failures. Real systems are designed expecting failures. For example, if one server becomes unhealthy, health check remove it from the load balancer and continue serving other healthy servers. Let's assume if any request fails, retry mechanism try again. In case of database, if one database replica fails, another replica can continue serving traffic. If an entire server crashes, auto-scaling systems can launch new instances. So the goal is simple. Failure should not bring down the entire application, and good distributed system isolate failures, recover automatically and continue serving users. Now, one important mindset shift is this. In distributed system, we do not try to avoid failure completely. This is impossible. Instead, we design systems that can survive failures. This is exactly how big companies like Google, AWS, Netflix think. Failure is expected, but resilience is engineered. So now you should have understand Distributed systems are not difficult because of scale alone. They are difficult because once multiple systems communicate, failure becomes much more complicated. And understanding these trade-offs is one of the most important skills in system design and cloud engineering.
So this concludes our today's video. I will see you in the next one. Till then, stay curious and keep learning.